Hello friends, today I am solving one of the problem from finite element analysis, that is on a triangular plate. Calculate the displacement and stress in a triangular plate fixed at one end and subjected to concentrated load at its free ends. Concentrated load at its free ends. The given or the assumptions what we have to make is, this is given in the question paper. So E is equal to 7 into 10 to the power 4 Newton per millimeter square, and T, thickness of the plate, that is 10 mm, and Poisson ratio, that is equal to 0.3. So now this is the given sketch. So this is plane stress and this is plane strain. So this problem is on plane stress. Okay, you have to check if the problem is given on plane strain or plane stress. Okay, you have to identify that, and after that you have to start the solution part. Here this is plane stress problem. So load 50 kilonewton is acting away. This load is acting away, so it is positive. And here load 100 newton is acting on the element, so it is negative. Okay, so here 50 is positive and 100 is negative. So solution part, I have redrawn the sketch here, mentioning the displacements and all the values here. So let's start with this. Q1 to Q6 are nodal displacement produced in global XY direction. Let's see the nodal displacements. They are x1 is 0, y1 is 0. So x2 is 30, y2 is 20, x3 is 0, y3 is 20, and these are the datas. So next, global stiffness matrix K is equal to B transpose D B A T. I consider it as an equation 1. So equation for B matrix, that is B is equal to 1 by J to this one. This is a theoretical part. Remember this equation. If they only or simply ask to calculate B matrix, then up to here you have to calculate. That will be for less mark. Or if they ask for further calculation, you have to proceed. So to calculate this B matrix, we have to find out J value first. So to find out J value, we have to have the area. So area of the triangle is equal to A equal to 1 by 2 B into H. H here thickness, so we have considered thickness as T, so H equal to T, so replace H by T, the value 20 it is given. B is width 30, 1 by 2, so you'll get area. So after that A is equal to J by 2, so you'll get the J value as 600. Okay, so next, so B value we have to find out. Now here they have given this matrix, so y23 this everything, so we have to substitute accordingly. So this values remember and this value alone. So here see y23, that is y2 minus y3, that is equal to 0. Similarly this all y3 minus y1, y12 is y1 minus y2, all these things you have to substitute these values and you have to get this answer. So here y2 in the place of y23 0, here 0, that was this was 0 earlier, here 20, 0 minus 20. Similarly here you have to substitute. So next, this one, this is 3 into 6 matrix, 3 row, so row is 3 and column is 6. This is row and top to bottom is column. So next, the transpose of B matrix is B transpose is equal to this 0, this 0 here, 20 here, 0 here, minus 20 here, 0 here. Similarly this to this way, and this one to this. So 1 by 600. So in order to avoid in the further step then big number, in order to avoid the big numbers here inside, so I'll make this big numbers to be reduced into this. So I have taken 10 inside, so 30 minus 30 by 10 is minus 3. Similarly for all these values, so you'll get this 6 into 3 matrix. This is a row, this is column. So next d is equal to E by 1 minus Poisson ratio. It should be by mistake I have written mu, so this is also Poisson ratio. This is Poisson symbol V, this one same Poisson symbol. So d is equal to E by 1 minus Poisson ratio square 1 Poisson ratio 0, and similarly keep on going. So replace, that's why I have written here replace mu by V, because that because of that error. So this is the thing which I have mentioned. So next d is equal to E value they have given, substitute that value, divided by 1 minus Poisson ratio is 0.3 square into 1 minus 0.30 0.3100001 minus 0.3 divided by 2. So next after this, what this will be 1 minus 0.3 square will be 91 by 100. Okay, so I have written this after I have solved this and this one. So next, see, 7 into 10 to the power 4 into 10 to the power 2 by 91, because this 100 goes up, that is 10 into 10, that is 10 to the power 2. So 1.30 0.31 0.35 is good to see here. It will be 10 to the power 4 into 10 to the power 2, that is 10 to the power 6 it will be. So to avoid 10 to the power 6, I have to avoid this 0.3 all these things, have taken 10 inside, so that I'll get better values. This is, so next substitute the values in equation 1. Equation 1 we have given, I have here, this is equation 1, this is equation 1. Now we have to substitute values, all values, b transpose d b a t, all values we are having. So start substitution, this one b transpose of b d b a t. So matrix, this is 6 into 3 3 into 3, this is 3 into 6. So initially we will start with this two. Okay, so when write this as it is, and here 10 into 0 for initially what we are, how the multiplication goes on is here like this, and this is like this. So 10 into 0 plus 10 into 0 plus 3, this 3 into this 0 0, 3 into 0 plus the 0 into minus 3 0 into minus 3. So how much? 10 into 0 0, 0 plus 3 into 0 0, 0 plus 0, this what 0 into minus 3 is 0 itself. So everything is 0, that is why this is 0. And next this one, for this one and this value, 10 into 0, that is 0, 3 into minus 3, that is minus 9 here, minus 9, because 0 into 0 is 0. So 0 minus 9 plus 0 is minus 9. Next this way into this, 10 into 2 20 plus 3 into 0, that is 0, 0 into 0 0. So 10 plus 0 plus 0, sorry 10 into 2 20 plus 0 plus 0, that is 20, like that. And this one to this one will give you fourth one, this and this will give you fifth one, this into this is fifth one, this into this is sixth one. Okay, and next for this second row, 3 into 0 0, 10 into 0 0, 0 into minus 3 0. So 0 plus 0 plus 0 0, that is 0. Next, for this one similarly, this into this, next this second one, okay, for second row. And for third row similarly you have to carry out, you will get this table. Okay, next, after getting this one, this will be a big table because 6 into 3 matrix, 3 into 6 matrix, this can be done. So it will be 6 into 6 matrix. Similar to that one, similar to this, you have to follow this one and you will get 6 into 6 matrix. So here this 7 into 5 divided by 91 into 300 into 10 divided by 60, here this 60 and this 60. Okay, so this will solve this, you'll get 6410.26 and rewrite this one here. After that we'll calculate the load vector. Okay, so load vector f equal to f1 x, f1y, f2x, f2y, f3x, f3y, that is equal to here given f1 x, f1y, and here they have given plane strain, that is 50 positive, and plane stress, that is minus 100, f3x, f3y. So the equilibrium equation, we know that k is into q is equal to f. So k value, you know it here, this one, this entire is k. And next, q are displacements, q1, q2, q3, q4, q5, q6. I have mentioned the displacement in the sketch. And the next is this one, the load vectors. Next, we'll solve this. See, now what we have to do is we have to apply the boundary conditions. The boundary condition is that, see here, which is fixed, which and all are fixed, we'll see which are all fixed. So q1, q2 are fixed and q5, q6 are fixed. Only q3, q4 are applied with the load, they are the free ends. So for that we'll apply the boundary condition now. So the boundary condition, this is q1, q2, q3, q4, q5, q6, similarly q1, q2, q3, q4, q5, q6. So now q1 is fixed, so we'll cut it off here. Then q2 same, gone. q3, q4 are there, they are the free ends. Now q5, this is gone, and q6, this is also gone. Okay, so now what remains is, so this is also gone, q5. Okay, now we will be having only these four values, q3, q4. Okay, so next, fixed nodes q1, q2, q5, q6 have been removed. So now 6420.26 into this 40 0 0 14, so that is q3, q4 displacements. 50 and minus 100 are load vectors. Next, see, solve this. q3, this 40 into q3 plus 0 into q4, that will be 40 q3. Next, same, 0 into q3 is 0 plus 14 into q4. So after solve like this, you'll get these two values. Okay, so this depending on the way how you use the calculator, these values changes. Okay, I mean fractions, 1.95 I have got, you may get 9486, 9476, that's why I made a full number. So don't forget to write the units. Units are very important here, not only here but in every mechanical related problems, or in the mechanical, units are very important. So next we'll see this one. So displacements, after calculation of these things, all this q3 also q4, will write the displacements. So q1, q2, q3, so q1 0, q2 0, q3 1.95 into 10 to the power minus 4 millimeter, just we got the value, and q4 is equal to minus 1.1143 into 10 to the power minus 3 millimeter. So the next q5 is 0, q6 is equal to 0 because these four are fixed. The displacement is 0 in this. So the next, stress in triangular plate. So we'll calculate the stress, that is sigma equal to dB displacement. Okay, displacement we use. So sigma is equal to this d, whatever the value is incorporated with the d, you have to write here the d value into b. So okay, yeah, so d and b value we have got, that is to avoid any extra calculation we'll use the same value which we have done here. See, d and b, so this is same values you have. See, 0 minus 9 20, 0 minus 29, 0 minus 36, 0 minus 6 30, minus 10.5, 0 0 7 10.5 minus 7, same value. So now into displacement, q1 q2 they are 0, this is q3 q4 q5 q6 are as well 0. So we'll solve this. Sigma is equal to this one 128.21 it is into, so same method, how you calculated this by multiplying dB, same you have to do this by, you have to this way multiply by this way, you'll get this value. Okay, so 0 into 0 0, minus 9 into 0 is 0, 0 plus 0 is 0, 20 into 1.95 into 10 to the power minus 4, 20 into 1.95 into 10 to the power minus 4. Okay, remember that, plus 0 into this one is 0, this 0 and this one is 0. So now remaining is 20 into 1.95 into 10 to the power minus 4. So if you multiply that, you will get this one. So my calculator is giving this full number, maybe yours also same, but sometimes you may get according to the fractions here, you may get this value also or any other different value, but this is important number, this 3 is very important, and fractions whichever you may get, that is not a big issue. So similarly for this one, 1.17 into 10 to the power minus 3, same, 0 into 0 minus 30 plus bracket open minus 30 into 0 plus 6 into 1.95 into 10 to the power minus 4 plus 0 into this one minus 6 into 0 30 into 0. So you'll get this value because 6 into 1.95 into 10 to the power 4 this is. So similarly for this one, this into this, 0 into 0, this 0 into 1.95 into 10 to the power minus 4 which is 0, 7 into minus 1.14, sorry 1.1143 into 10 to the power minus 3, and 10.5 into 0, that is 0, minus 7 into 0 is 0. So what we will get is only this one, this one, this 7 and see, 7 and this one, so you'll get this one. So after that, multiply this one 128.21 with this and with this, so you'll get these three values of stress in a triangular plate. This is the unit, don't forget to write that, and later at the end we will write the displacement in triangular plate, that is 0 q1, this is q2, this is q3, and this is q4, and this is q5 q6 transposed. Okay, that is your answer, it is in terms of millimeter. So this is your answer for the triangular plate problem, that is this stress in displacement and stress in a triangular plate. Thank you.